Okay, good morning. I'm planning on doing the LeetCode contest from last Saturday. Let me secure my screen here. Okay. Open up LeetCode and let's see. So contest 300. So I plan on doing that virtually. So here we go. Okay. All right, open these up. 3, 4, 5, and 6. Okay. Decode the message, given the strings key and message, which represent the cipher key and secret message respectively. The steps to decode message are as follows. Use first appearance of all 26 lowercase characters and key as the order of the substitution table. Align the substitution table with the regular alphabet. Each letter and message is in substitute. Okay, so we swap them based upon their order. So we can use a map. Let's see, 6:53 a.m. How many minutes for game plan? Use a map and to store the mapping between the lexicographical order and the order in the message of characters. Oops. Characters A.Z. Then return the transformed message, right? That's the game plan, 6:54. Got 1 minute for game plan, and then we'll start the execution or the implementation, 6:54 a.m. 4 a.m. dash whatever. 9 minutes for the implementation in Python 3. Annotation. Okay, so this is our key. This is our string. Let's do it like that. As M will be our dictionary, and then it's the first instance of each letter. The first appearance is the order. For C and key. Oh, actually, let's do this. Let's just do map will be an array, which you can push back upon. Or no, let's do. We need the keys A through Z inclusive, so they can go through slots 0 to 25. Based on ordinal value, and that might work. Yeah, that should be okay. Right, so this guy will be some character. We'll just say it's star times 26. Okay, so we use the ASCII ordinal values to map there. Exit ordinal value of the character and the key. If m sub x equals, is it not equal star, then we'll continue. Otherwise, m sub x equals, oops, m sub c equals m sub x equals c. Ordinal value of that minus the ordinal value of a, like offset by 0. Just call it the index. Okay, so that's that, and then return m sub ordinal of C for C and S dot split. Oops, let's type this just. Join it together. Oops. Does that work? Maybe. Let's see. Uh-oh. This index out of range. I is out of range. So lowercase ASCII ordinal values. What am I doing wrong here? I. Ordinal value of that minus A should be offset to 0. Negative 65. Oh, because of the space. Okay. Okay. If C equals a white space, then we'll continue. Sure, it's taking a while. Okay. Oops. What? Oh crap. Okay, so the white space really does ruin this for me. Split it into words, I guess you could do that. Right, let's do that then. Fine, whatever. A equals S dot split based on white space. So that'll be the words. For word in A. So key dot split. Character in the word. Don't worry about white space. Let's do this. Split on white space, and we don't even need an array. Character in the word. Okay. Oops, no, joint with the white space. What is going on here? How is ordinal value C and S? This sure is a pain, this white space. Expected character, but a string of length 4 was found. Oh. Okay, so each character of the word for each word in the split based upon white space of the sentence, and it's still not cool. Okay, so I'm just hacking at this thing. I just wasted some time. 6 minutes. Okay, here. Okay, well, white space is giving me a hard time with the implementation. How can I make this easier on myself, right? I want to keep it super simple. I want to just map the character if it doesn't already exist and then change each character in the string. If it's in the mapping. I feel like I was pretty close, but there's room for improvement, obviously. Right, so let's just do this and then keep it simple, keep it simple. If white space goes to white space will be the default. If character equals white space, then we'll continue, right? We already have that mapping in place. Otherwise, if character is not in M, right, it doesn't exist in the mapping, then we'll map it with the next value from 0 to 25 inclusive. 0. Let's do this. Actually, just call this offset just to keep things simple. So what do we want to call this one? The next alphabetical value. We'll just call it X, whatever, it doesn't matter. The ordinal value of A plus offset, let's equals 1, we'll give it that. And we want to turn this thing into a character. Right, so M sub C is encoded as X. That character in the key is the next alphabetical order from A to C inclusive. Okay, and then we should just be able to say turn join list of S for each character in the list of S. We'll map it to M sub C, the mapping of that character for a character in the list. We took out of the white space by having that its default. Character is not in M. Take care of that. Okay, that looks good. Big money, no whammies. This is a secret. Okay, that's cool. And then the 5 boxing wizard jump quickly. I like that. That's awesome. Okay, let's see. All right, that was cool. Okay. Come on, big money, no whammies. Yay. Okay, cool. So 7 to 704. All right, just regroup, keep it positive. You know, obviously it's not terribly too overly complex, but I was starting to spin my wheels a little bit, which results in AC. Yay. Okay, so let's let's do the same for the other languages and then move on. A few solutions. On 3. Use a map M to associate characters C of the inputs key with the graphical order A to Z inclusive to transform the input string S. All right, Kotlin, JavaScript. That's cool. And then let's do Rust. And we'll do C++ too. Okay, that should be enough. And let's get going. Okay, there's our key, our string, using a map. We are unordered map of characters to characters. For each character in the key. I have an offset as well. Okay, and then let's do this. Let's initialize the space to a space, and then if m.find c equals m.end, then we can add it onto the mapping. So let's keep that there. Okay, so x will equal a character. Let's do a character. A plus offset plus. Should be okay. And then m sub c is equal to x. Okay. And then let's create a new string t, which will transform s into. It's basically like a mapping. Server t. Oops. This guy. Character and string, and we'll return t at the end. Return m sub c. Okay. That looks good. Uh-oh. M cannot be implicit. That's right. Gotta grab that guy by reference within the lambda. Looks good. And LeetCode's running really slow. Okay, there it goes. Like, did I hit submit? I think I hit submit. Okay, that's cool. Okay, let's do JavaScript next. Okay, there's our key, this is our string, m is our new map, offset is 0. Okay. And for let's see key dot split. Actually, let's do this. Mapping default space to space. Life easier on myself. And if not m dot has a character, and x equal a, let's do an ordinal here real quick. Ord equals see that char code at 0 ordinal value. So do ordinal value of a plus offset plus plus transformed into a character. Let's see. Character dot from char code. Get something like that. And m dot set seed x, and then we'll return s dot split dot map each character to m dot get the character join. Okay, that looks good. Uh-oh. New map. Iterator value is not a map entry object. You need to have a pair like that. Okay. Uh-oh. Character from char code. Okay, JavaScript from char code. String dot from char code. Okay. String. Okay. Looks good. Looks good. Okay. There's JavaScript. Let's do this. Move this guy down below Python. Okay, we'll do Kotlin and then Rust and then move on. All right, let's go. Let's go. Okay. RM is a mutable map, character to character. Oops. All right. So for let's see of key dot to char array. Right through. If not map contains character x equal a dot to int plus offset plus plus. Offset is 0 initially. And then we need to do a character from that. I forget how to do that. Hold on. Kotlin character, mask key, ordinal value. String.toInt, step 2 string. Two byte.toInt. Two byte.toInt. Two-int is fine, but I want to go the other way. Two char. Kotlin. Two char. Oh, does that work? Integer value character. Okay. Two char. M sub x equals c, or m sub c equals x. Oops. It's back to that. Okay, and then return s dot two char array dot map m sub it dot join to string. Okay. Big money, no whammies. Uh-oh. Oh no, no pointer exception. Holy cow. Pointer exception. M sub it must be null somehow. Oh, I need the pair white space. That white space is really giving me a hard time. Make it easier on myself, setting the default value there. That's cool. Come on, come on, come on. Okay, good. Okay, let's do this in Rust and move on. That unit offset equals 0. That unit m. Let's use SD functions hash map. Hash map. Okay, and then for C and key dot chars, if not m dot contains. To borrow that character, I don't know. Let's see. If it doesn't contain it, then let x equal Rust ASCII ordinal value of character. 2-digit radix. 2-digit. C dot 2-digit base radix. So just increment by 1. 2-digit, and then Rust ASCII character 2 char. Ordinal value to character. Right, go back to this char from U32 dot unwrap. from U32. Not insert that character, and we'll return s.chars map each character m dot get the character dot unwrap dot collect to a string. Okay, something like that. Come on, LeetCode, compile that thing. Let's go. Contains, to borrow it there and unwrap it there. Borrow this, contains key. I'm gonna borrow that thing. And then cannot be built from an iterator of optional characters. To unwrap. No, get to unwrap. Really? Into iter. Does that work? I don't know. I might have to come back and work on this one. From iterator is not implemented for string. Optional characters. Thought that I was unwrapping them, so they're no longer optional characters. Chars.integer. Does that work? I don't know. I want to move it. Optional characters that are borrowed. Unwrap. Does that work? Well, that sucks. I wonder if we can move it into a vector of characters and do a string from. I don't know. And the rest is weird. I got to work on this for sure. String from is not cool. It's not implemented for that thing either. Okay, to do, we'll come back to this. Implement me. I'll do that later if I have time, whatever. Okay, that's cool, right? Use the map to associate character C with input key with lexicographical order A through Z inclusive to transform the input string as. All right. Good enough. Okay, so that took about 30 minutes. Okay, so about 1 hour left in the contest. Remaining remaining in the contest. Okay, what do we got here? Going to integers M&M. Spiral order clockwise. Up, right, down, left, based upon what's been seen. Return the generated matrix given the linked list. Okay, that should be fine. So iterate through each cell I, J, starting at 0, 0, and move in clockwise order. Up, right, down, left. Checking what's been seen. Right, out of bounds, plus what's been seen. That's the game plan. Let's start implementing this. Let's get going. It's for implementation in Python 3. Okay, implementation. Okay, M rows and N columns. That is the head. So node equals head. And then the matrix will be an array of n columns for each m rows. There's our array. So return as the solution in the end, and then HA was 0, 0. Seen. Seen equals a set of coordinates. This would be tuples that have been seen. Okay, I'm just going to start with 0, 0 as the first tuple. Just do this. All right, so there's at least one. Okay, so A sub. Okay, let's put it there and then move, put it there and then move, right? So direction. Let's do this. Ders equals the offsets, the delta of I and J up. Down, left. Oops. Okay, so kth direction, how about kth directions, clockwise order, up, right, down, left. Okay, so while let's do this for, doesn't matter, in range n times n. I'm going to move through that many cells. As long as the next movement is okay, then take it. Happening here. So a sub I sub j is equal to the node value. Node equals node dot next. Not true. This, right? So let's say let's do this. The outer loop take care of all ij cells iteration, and then next ij depend on if it's out of bounds or already been seen. Seen equals a set. So seen dot add to ij. ej equals stirs. Okay. Let's see. UV is I plus DMI, J plus DJ. If zero resistance will be used, and it's unbound basically. And UV not in the scene, then it's cool. We can add or assign I to U and J to V. IJ equals UV and move on. Otherwise, if it's out of bounds, then we're already saying we're going to move to the next direction. Okay, oops, else, okay, plus equals 1. Let's see if not this. Okay, plus equals 1. Volume here. Yeah, kids are extremely loud. Okay, so I want to go around. If it's out of bounds or it's seen, then just go to the next direction. Let's see, okay, it's false. Oops. Ones. A plus equals 1. Let's do this break in this case. Okay, so we're either going to find the next cell in the current direction or go to the next direction. K equals K plus 1 modulus length of directions, which is 4. Loop it back around. Okay. So the loop invariant here is the ij cell is the next unseen cell that needs to be filled in. Write that thing. Okay, so that looks good. Something like that. Runtime arrow. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Oh, they're negative ones. Okay. All this then. While node, no node dot next is nothing, it'll just exit. It needs to be set to -1. Okay, I think that looks right. 3026850 -181 1. Yeah, it looks right. Okay, 0 2 0 1 2 -1 2 -1. Let's go LeetCode. Come on. This thing gets stuck. Oh, there it goes. Okay. Okay, that's good. Big money, no whammies. Oh no, time limit exceeded. What? Okay. 7:35. 9 minutes for implementation, which results in TLE. Okay, something's not right here. 10, 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Node. If the node doesn't exist at the end here, then we'll just exit that. All right, end up going out of bounds. Okay, let's see. So that's a corner case at the end that looks right. 10 rows by 1 column. Okay. Looks good. Okay, accepted. That took about 1 minute to fix. 1 minute to fix bug. It gets stuck. What a corner case. And there's nothing left to do. No. Very right. Just tail. Okay, so that's good. Let's post this guy and move on. Nothing too fancy, right? Keep it super simple. Come on, come on, come on. A few solutions. 3. Oh, you know what? I'm not actually adding anything to scene, so hold on. This is not UV, not in scene. Oh, I haven't added to scene there. Okay. Yeah, that's okay. Let's see. Let's do this. IJK node scene. Yeah, whatever. It's fine, right? Yeah, it doesn't have to be perfect. It's good enough. Let's move on. Okay, do this in C++. Let's see, JavaScript. And okay, let's not take too much time. I want to get to Q3 and Q4, so 7:39 hour minutes for implementation. C++. Integers, vector, integers. Okay, and head I a is what we'll return at the end, and that is m rows of n columns initialized to -1 each, while head j and k jk tuple 0 using set is onward, or actually it's just seen word map of int word map int spool default to not seen. It's seen goes for each ID cell. All right. Scenes of ij is true. We set a sub ij equal to the node value. Node equals node next node. Go to the next unseen cell. Let's do this. VBIgers equals relative offsets up, right, down, left. Actually, let's do this so we can destructure it. Let's do pair, int pairs, vector, pair, pairs, and destructure those pairs. Dij equals pairs sub k. UV, make tuple, make pair, but plus di, j plus dj. If 0 is less than equal to U and U is less than N, vector inbounds, and V is less than N, and not seen sub U sub V. Cool. Equals U, J equals V, break out there. Otherwise, increment K by 1, mod it 2, K equals K plus 1 modulus dir size, so you wrap around. Okay. Looks good. Looks good. Big money, no whammies. All right. 739, 743. 4 minutes for implementation, 0/, which results in AC. Yay. Okay. This. Let's do that there. Okay, let's do it again in JavaScript. 7:44 a.m. It's for implementation in JavaScript. Okay, M and head and C equals a new set. Key equals IJ. This is a key for a map. Tools, IJ scene cells. All right, and then A equals array of M rows. We map each row to random columns. Fill up with the default value of -1. Turn it at the end, and then while node was head. Good. V sub I sub j equals node dot value. Node equals node dot next scene dot add EIJ. All nodes to exist. We're going to go through and find the next QV adjacent to IJ that hasn't been seen. There's equals the relative offsets clockwise over up, right, down, left, UV equals DIDJ, difference folders. Okay. UV equals I plus DI, J plus DJ. If these are inbounds, spam, C, and these is N, and not seen as key UV I J equals UV and the break. Otherwise, K equals K plus 1 modulus. So wrap around. No. Okay, that looks good. Come on, LeetCode. Run it. There we go. Uh-oh. A sub IJ, I is not defined. Oh, oops, okay. IJK needs to be defined. IJK 0, 0, 0. Okay. Looks good. 7:44, 7:47. 3 minutes for implementation JavaScript, which results in AC. Yay. Okay, grab this guy, stick it here, jam in Kotlin, and move on to Q3. Okay. A is array of array size m filled in with int arrays size n initialized to -1 at the end and node equals head. The node is not null. Scene is a mutable set of strings which will have a key. Key is a lambda. J cells. Transform to tuple or to a string like that. Okay, and then good. IJK equals triple 0, 0, 0, and then we need some directions. Rulers, walls, list of here, up, right, down, directions. Okay, and then a sub I sub j equals node volume. Node equals node. Next. Scene to add key ij. Null. Move on to the next adjacent cell. Di dj is the destructured direction, kth direction. uv equals I plus di, chips, I, j plus dj. If it's inbounds, use to j equals v, break. Otherwise, k equals 1 modulus or size. Okay. Whoa. Oh. Pair we destructure. Middle set cannot be invoked as a function, seen that contains. Looks good. Okay, that's cool. Good enough. Okay. Traverse the linked list and the output matrix cells I, J in clockwise order. Up, right, down, left. Each adjacent cell U, V, I don't need to explain it. You can read the code, right? Traverse the linked list in parallel with the traversal of the output matrix. Starting at cell 0. Top left, cell 0. Right, traverse each linked list node starting at head in parallel with the traversal of the output matrix cells I, J in clockwise order, up, right, down, left, starting at top cell 0, 0. Right, that's okay. I guess keep track of out of. So I guess maybe we. I guess turn right when encountering out of bounds or a previously seen cell. Okay. Traverses last nodes starting at head in parallel with the traversal of the output matrix cells I, J in clockwise order, right, down, left, starting at top left cell 0, 0. I return right when encountering out of bounds or previously seen cell. Right, that's cool. By looping through kth direction. When we encounter good enough, right? Considering each next candidate cell U, V. Well, that's good enough, right? Nothing too fancy. Okay. Post it. Diversity extent this node starting at head in parallel with the traversal of the output matrix cells IJ in clockwise order, up, right, down, left, starting at top left cell 0, 0. I return right by looping through each kth direction. When we encounter out of bounds or a previously seen cell, when we consider each next candidate cell UV, right? Oh, looks good to me. Could be worse, could be better. Oh, whatever, it doesn't have to be perfect. Okay, we got 25 minutes left in the contest on Q3. 25 minutes remaining in contest. Okay. Oh, I do. Okay. one person discovers a secret. Suppose the first person named A. A shares the secrets with another person B. 2 people, 3 people. A forgets the secret on day 5. He shares a secret with E. C shares a secret with F. Shared layout means that each person will share a secret with a new person every day. After discovering the secret, get takes 2 days for this one to be shared. Delays less than forget. So it does increase. So this one seems like best ending here, like a cadence type algorithm. Right, offhand. This looks like TP. And we remember the past, right? Past to formulate future. And maybe a candidate. Best ending here each like day till n. Okay, so it's non-inclusive of the last day. I'll be right back. Are people aware of the secret? Okay, let's work through an example here. Okay, so first person on day 1 in is at least 2. Okay, so let dp sub I denote the number of people who know the secret on the ith day. And we start with dp sub 1 equals 1. We don't need to use index 0. And we want to fill in from on equals 1 to inclusive. And we return dp sub n. Don't forget the mod by 1.9 plus 7. dp sub 1 is 1. dp equals 0 times n. Okay, so two, 3, 4, 5, 6, 7. Okay, so n is 6. dp said that, okay. So this guy is set to 1 initially. And then this dude 1, he knows it. Oops. He knows the secret. Until 4 non-inclusive. At day 5, he forgets it, right? It's okay here. At this point, it's no good. Okay, and then delay. Let's see what the new person B. Day 3, because that's delay. So this offset here, oops. Oh, hold on. This offset is delay, or forget. And the other thing is we send it to the next guy. Delay B plus 2. So we give it to the next guy. It's 4 delays 2. So it's plus 1 airplane. Previous one. So this would be -1 here, and then this is plus 1 here. Right, and then the previous day of known people is the current day of known people. Right, so we do a memory optimization later on for I in range 2 until n plus 1 non-inclusive till n inclusive, right? So dp sub I equals dp sub I minus 1, right? The previous non-unknown people. And then delay is when we add 1, right? Plus equals. So if I plus delay is less than or equal to n, dp sub I plus delay, oops, with 1. Right, this person will let someone else know. dp sub I plus modulus at odd equals 29 plus 7. That guy's plus 1. Just mod, okay. If I plus forget, so let's go to n. Spell this one add and this one subtract. I'll add. And this guy's sub. Is an I plus sub minus equals 1. Sub n. Okay, something like that maybe. Okay, let's see, is 3 is not right. Nope. Let's walk through the simulation of what occurs here and what went wrong. Okay, so dp equals 1, 0, 1, 2, 3, 4, 5, 6. Okay. I equals 0, 1, 2, 3, 4, 5, 6, 6, 7. Okay. That's initially. After a process, initially it's this, okay. Okay. Let's do this. Okay, so I is here. dp sub that equals that plus that, right? That's just that guy. Oh, at 1 we need to, okay, I'm missing 1, right? That's fine. Okay, cool. That works out well for the base case actually being 0. Okay, so that is off by 1. No, it's still 3. Okay, so that's not right. Okay, so anyhow, I'm gonna say add equals 2, subtract equals 4, right? So plus 2, we'll do plus 1, then minus 1 here. For I equals 1, right? I equals 1. It's itself plus the previous, and then hold on. This guy's 0, this guy's 0. Okay, so plus 1 for add, which is I plus 2, and I plus 4 is negative 1. Okay, so looks right. I equals 1, and I equals 2. 2 plus 1, or plus the previous, right? And then plus 1 here, minus 1 there. Okay, it's 3 plus 1 here. And Oh wait, hold on, it's plus itself. Previous, what's that? Plus one here. The other one's off. Some count. Okay, so I see how this is wrong now. Okay, so this one's the previous, and then this guy goes to 0. So I need to have it be the maximum of 0 and -1 plus itself. So it doesn't go below 0. Okay, and then one should be 6. Uh-oh. That's not right. Okay, so it worked out for the first one, but it didn't work out for the second one. Something's not right here. How much time do we have left? We have 8 minutes. Okay, I'm gonna be pushing it for answer in 3 here. Okay, this solution works okay for example 1. Oops. That fails for example 2. So something's not quite right here. Let's walk through this. Okay. It's 1 through 5. So DP 0, 1, 2, 3, 4, 5. 2, 3, 4. 0, 1, 2, 3, 4 inclusive, right? Okay. So an I is 1. Delay is 1. So this guy goes up to 1. This guy stays at 0. Okay, an I equals 2. Add that to the previous. Tell one more person there. Subtracting is out of bounds. 3. And this guy should be 4. Okay, so that's why I end up with 4 there. So what's wrong? The first person is named A, or one person, shares a secret with B, which is 2 people. Both A and B share with 2 new people. And we need to multiply it. The amount that it knows currently goes on from there. So it should be 2, and then another 2. Okay, so that's what's wrong then, right? Okay, so this will be a clutch move, but I think I can get it. Let's see. 6 minutes. We can do it. We can do it. I think I can. I think I can. I think I can. And so we need to take plus equals dp sub I. So, right, how many people here tell that many people there? How many people forget? This dp sub I. 8 and 8. No, that's not right. Okay, so something's not quite right with my recurrence relation here. So how many people forgets the secret? He forgets the secret here. Maybe I do want to go down then. Yes, D sub E sub I. People that totally forget it could be negative, right? 6 and 7. Okay, it's off by 1. Okay, so might not get it. 3 minutes, okay. Out. 6 and 7. That's not quite right. Kind of ballpark there, but not quite right. So I'll probably upsolve this one. I don't know if we'll get in 3 minutes or not. Let's walk through these stories and see where I went wrong. Okay, so example 1. Okay, this is person A we're saying here. A shares it with 0, 1, 2, 3, 4, 5, 6. I'm gonna share it with person B. 3. Still the only person that knows it. Okay, that looks right. A and B. He knows it here. And then these two people will share it with he shares a secret with a new person C on day 4. A's the only person who knows a secret. A shares it with B. Does A share it with anyone? Yeah. At this point, A shares it with C, right? A, B, B, and then C. C would know it from here. This is where A tells B. Plus 2, right? And then here A tells C. A forgets the secret at day 5. A till D here. It's not quite right that A tells D here. Because A forgot the secret before then. A can't, this cannot happen, right? Cannot occur because A forgets. A forgets at what? A forgets at 5. So we should add 1, but then we should also have subtracted 1. Subtract 1. Count that forward at that point. So we'll add it, but it'll subtract it as well. All right, needs to take that into account. Is that right? 6 and 7 is not right now. Okay, well, the contest ended. I'm pretty close, but you just go slow and think about this a little more methodically. I think I'm on the right track there. So yeah, catch you next time.